All right. So good morning. How's everyone doing? So well. Good. All right. Remember. Okay, are we ready? Kaylee and Lydia were the last ones talking. That's weird. Just kidding. All right. So yesterday we talked more about using a box model to represent a chance process, and we focused on roulette and the different bets on a roulette wheel that you could make. And we're actually going to refer to that in just a few minutes. But chapter 17 focuses on what's called the expected value and the standard error. Okay, so I want you to imagine that we have a box model. Is everyone listen? That that we have a box and it has tickets of 0, 2, 3, 4, and 6. Okay, and we are going to draw 25 times from this with replacement. So one set of 25 draws could look like this, have these numbers, and if we add them all up, the sum would be 66. Then we could do it again, repeat the process. Here's another set of numbers, sum could be 61. Okay, another one, sum could be 62. So as you can see, the sum won't be the same every time, correct? It may vary. But hold on. Let's think about how many zeros do you expect to get in 25 draws? 5? 5? Okay, all right, what makes you say 5? What makes you say 5, Dallin? Five. Exactly. Exactly, right? So you're like, okay, this is the probability of getting a 0. This is how many draws we're doing, so we should expect 5. Okay? All right. Great thinking. I like that. What about 2s? 3s? 4s? 6s? Okay, they're all the same. So what do you would expect about 5 of each? What do you expect the sum to be? Because I know the previous slide we had about 60 something, right? Oh, okay. So you're adding 5 of each. Okay, I like that. That's a great idea. Okay. All right. So that brings us to, well, there's this formula that helps us find that expected value. So this should be in your notes. So it should be the expected value for the sum of the draws is, and then there's a blank, and in the blank I want you to write this formula. So this is a formula. Make it big and bold, highlight. So what is referred to as the EV sum. So from now on, whenever we say EV, that means expected value. It's just faster to use that. So the EV sum is the number of draws times the average of the box. Okay, that's the EV sum. And then the standard error for the sum of the draws is SE sum equals square root of number of draws times SD of the box. So just make sure you write that formula in that little blank below. Okay, so a little bit more about expected value and the standard error. Wait, raise your hand if you have the formulas written down for both. Are we ready? That's good. That is good. Okay, so The average of the box, if we were to average up these numbers, so 0 plus 2 plus 3 plus 4 plus 6 divided by 5 numbers, the average would be 3. Okay, are we listening? So then, and the SD of the box, if we put all these numbers in a list in the calculator and we found the SD, then the SD would be 2. All right, so then to find the EV sum, the number of draws is 25 times the average of the box is 3. So the EV sum should be 75. That's what we expect the sum to be, okay? And the standard error, which is how much the sum could be off. Are we okay? Stop. Oh. So the SE sum would be the square root of the number of draws. So square root of 25 is 5 times the SE of the box was 2. So that 10 means that's the standard error we'll get while taking that sum, right? So that's like the give or take that is reasonable, okay? So back in the previous slide, if we expect a sum of 75, give or take 10, are these all pretty reasonable? Yeah, these are a little bit lower than that, but anyway. So that's how we calculate. So what do the EV sum and SE sum tell us? Okay, so ignore this right now. EV sum tells us the average of the sum of the draws. Okay, so that should be in your notes. So the EV sum tells us the average that as we sum each draw. And the SE sum tells us the SD of the sum of the draws. And then if we repeat the 25 draws many times, we expect the sum of the draws to be around the EV sum with an SD of the SE sum. Mm-hmm. I'm sure. All right, so if we repeat the 25 draws many times, we expect the sum to be the EV sum and the SD to match to be the SE sum, okay? So now, okay, let's go to your examples the first day that we did the box model, the examples 6, 7, and 8, okay? I want you on those 3 to find just the SD of each of those boxes. And this is on your own. So I don't want you working with your partner because I'm going to have you answer individually in just a second. So with your calculator, really? That's, I don't know if that's good, Jordan. What? So in the list and spreadsheets, put those numbers that are on the tickets, right? So like number example 6, there's 6 tickets. So make sure you put in those 6 numbers, right? And then list 2 would be 6 numbers as well, but some are negatives, right? you guys see what I'm saying? And then yeah. And the next one would be 5 negative 1s and 1 positive 10, right? On example 7. Right? We are wanting to find the standard deviation of the box. So we got to put what's on the tickets. This one, the sigma x. Okay? So when you do menu 411 and the SD of the list, find that one.